Hi, welcome back to the AUV modeling group here. We are basing off of the REMIS 100 model, and this is an update for assignment 2.
So one of the main things we had to focus on this week was ethics, mainly development and professional. So for development, we really focused on the source of materials, misuse of technology, the quality of the product, and the communication. Misuse of technology can be in a variety of different ways, and the quality of the product is pretty straightforward, but those are very important things. And then for the professional, ethics, integrity, patent law, and crediting contributors. Those are just all important in any project, but for ours specifically, it mainly focuses on the creation of the REMIS and not the REMIS itself. Yeah.
Part of that crediting is crediting Timothy Prestero, who we got some of our reports for about kind of the dimensions and the analysis of the REMIS itself from he's the founder and CEO of Design That Matters. We also got some resources from a previous group that had worked on this problem and of trying to model the REMIS system, and we also had a report about the state space and the command and control systems and the feedback for the controller. Those are several reports that we've looked at to build our work off of.
From the Timothy Prestero report that Asher just mentioned, we got this graphic, which helps us visualize how we model our AUV. As you can see, there are 6 different degrees of freedom. There is translation and rotation about each of these axes, X, Y, and Z, each with a fancy name like surge, roll, heave, yaw, sway, pitch, etc. So to completely model this submarine, we'd need all 6 to be defined with transfer functions, but we decided to only model with 2. So next slide, I believe it's Kaiden. Or Cheyenne, my bad.
All right, so the transfer functions that we're going to be focusing on the most here are going to be the inner loop transfer function, that is the pitch control, and then the outer loop transfer function, which is depth control here. We did get these transfer functions from some of the resources that we were looking at, so we're still building off of that a little bit. One thing that's important to recognize is that the inner loop operates much faster than the outer loop, and that both of these transfer functions are error state transfer functions.
So we also got a Simulink model from the previous work that was done with this REMIS 100 device. This again is just focusing on 2 of the degrees of freedom, the pitch control and the depth control. So basically we're only looking in the XZ plane. To start off, we have our depth reference, which is that blue box on the very bottom left corner. That's fed into the depth controller, which is then in turn fed into the inner loop. And as Cheyenne was saying, that's for the pitch control. And this iterates very quickly because it has to continuously vary the pitch of the rudder so that it can keep on track if there's any turbulence or anything in its path. And so there's 2 plants inside there, the pitch controller, which is labeled by PID, and then the pitch plant, which we're still working out. And that has 2 outputs, one that goes back into the outer loop, which is the depth plant, and one that goes into that observer box, the purple box in the middle. The observer box then feeds into the fault detection, which is out of scope for our current project. So we're just basically focusing on the very bottom line. And after it goes out of the depth plant on that bottom line, that's basically then our output, which is our depth. So yeah, pretty simpler than what it looks like, but.
All right, so on this screen, we've got all the contact information for any members of the group if anybody would like to follow up or has additional questions. In the meantime, we're just going to continue working on this project, and we look forward to having a completed project at the end. Thank you so much.